A simple question that people have been concerned with for thousands of years, whether in their own family or in plant and animal breeding. How are certain properties and characteristics inherited? Why do some traits disappear in one generation and reappear in another? Whether it's grandfather's Roman nose or mom's talent for music, a sheep's thick coat or a cow's milk production. Despite great scientific progress, mankind had not found a clear answer by the 19th century. All of mankind? No. Around 1855, the monk Gregor Mendel began a simple experiment that would finally answer this question in his monastery garden in Brno, Moravia. Over a period of several years, he grew tens of thousands of pea plants and meticulously documented the traits of their offspring over countless generations. An enormously laborious task that had simply never been done before. Mendel strictly used statistical methods to analyze the distribution of only 7 traits, a manageable number that enabled him to keep track of all possible combinations. 8 years of research yielded fascinating results. One and the same strange ratio kept cropping up among the descendants of the second generation, 3:1. For every 3 purple-flowered plants, there was 1 white-flowered plant. For every 3 plants with yellow peas, there was 1 plant with green peas. The basis of these famous Mendelian rules was his astonishing realization that in inheritance some kind of element or factor must be transferred onto the child from each parent, exactly what we call genes today. This put Mendel far ahead of his time. In 1865, he summarized his results and held 2 lectures at the Natural Research Association in his hometown Brno, followed by the famous essay Experiments on Plant Hybrids in 1866, published in this volume of the Association's periodical. Although this volume was sent to more than 130 scientific institutions around the world and a special edition of 40 copies to well-known scientists, Mendel's work was not noticed or its importance wasn't understood. For over 30 years, this milestone in science fell into a kind of deep slumber. It was not until 1900 that 3 works by notable scientists that confirmed Mendel's findings were released. Mendel had finally been resurrected. Subsequent works demonstrated the validity of his inheritance rules for animals too. And in the 1930s, it was recognized that these rules could also explain the mechanism of natural selection. Today, Mendel is known as the father of modern genetics, and his rules of inheritance are an integral part of school biology. Genetically spoken, after an initially recessive phase, his work had become a dominant part of mankind's knowledge.